Okay, hello and welcome to this tutorial. We're going to be looking at how we configure and verify spanning tree on Cisco switches. Now here's the good news. By default, spanning tree is enabled on all Cisco switches. So our work is done for us, the tutorial is over. Well, not quite. There's actually a fair amount of configuration changes we can make that all relate back to the features that we've discussed so far. So in this tutorial, we'll start off by looking at a few verification commands to get a sense of how a switch is functioning in its default behavior. And then we'll go ahead and we'll figure out how to configure the root bridge on a network. We'll take a look at configuring port cost, PortFast, BPDU Guard, root guard, uplink fast, and backbone fast. These are all optional configurations, and it seems like a lot, but really each one is pretty simple, and there's not a lot to each one in terms of the number of commands you need to issue. In terms of our lab, we're just going to start off with two switches, switch A and B, and they have a trunk between them, and there are numerous VLANs, as you'll see soon, enabled on that trunk. Okay, we're on switch A, and I want to begin by just showing you all the VLANs we have configured. So it's 1 through 10, 22, and 99. Now let's say I want to see just the current spanning tree information for any particular VLAN. The command I want to enter is show spanning tree, VLAN, and then the VLAN ID. So let's choose VLAN 4. At the top here, I'm given all the information I need about the root bridge for VLAN 4. I can see the ID, so I have the priority, and I have the address, the MAC address. Now, if you look at the priority, you can see it's 32,772. Now, we know the default priority value is 32,768. Now, why is this higher than that? Because we are using default values. Well, this is known as the extended system ID, and all that means is that you have the default value of 32,768, but then you add the value of the VLAN ID. So we're adding 4 to that number, and that gives us 32,772. We benefit by doing this because we get a unique bridge ID for each VLAN. Okay? So after that, I can see the cost. That's the path cost in order to get to the root bridge. And this is really convenient. They actually tell me which port is my root port, FA024. Now just below that, I have the local bridge information. So bridge ID here refers to switch A. So again, I learned the priority, and you can see it's the same as the root bridge. I have the MAC address of my local switch. And then if we scroll down a little bit more, we can see some information about all the interfaces that are associated with this VLAN. So currently there's just one, and we can see that it's FA024. It tells us the spanning tree role, which is, this is a root port for us. It's telling us the state, and FWD means it's in a forwarding state. And again, we see the path cost to the root. Okay, so this is a very useful command to issue, and we did it for just one VLAN. If I wanted to do it for all the VLANs, you just take off the VLAN 4 information, and now I can just cycle through every VLAN. So now we see VLAN 2, VLAN 3, and it'll just keep going. I'll quit out of that command. Now, if I want to cheat a little bit and quickly find out the root information for each VLAN, I can use a different command. And since I have a lot of VLANs, this is going to be very convenient to use. The command is show spanning tree root. What we get is a list of all the configured VLANs, and we learn the priority and MAC address of the root bridge for each VLAN, and then we learn the cost to get there, and some of the timer information. You can see max age, forward delay, but most importantly, we see the root bridge information listed on the end. And I can just scroll down to the bottom, and you can see we have every VLAN presented. So these basic verification commands can quickly enable you to figure out how a spanning tree is behaving for any particular VLAN. So you might have noticed that all of the VLANs configured on switch A have a root port of FA024. That means switch A is not the root bridge for any of our VLANs. So first let's look at how we can configure switch A to be the root bridge for a particular VLAN. And we have two ways to do this. The first one is by using the command spanning tree VLAN, and we choose a number. Let's start with VLAN 4. And in this particular method, we're going to explicitly set the priority. And if I show you the parameter here, it's just a value between 0 and 61440. But you'll notice we have to issue it in increments of 4096. So if I issue something like 500, I get an error message, and then it actually tells me the values for me that I can use. So these are all increments of 4096. So let's go ahead and do that. Remember, the lower the better. So if I issue 4096, the only way that another switch can be the root bridge for VLAN 4 is to have a similar priority but a better MAC address, a lower MAC address, or have their priority set to 0. So we'll jump out of configuration mode, and now let's take a look. Show spanning tree VLAN 4, and the information is a little bit different now. If we look at the root ID, we have the priority 4100, right? Because 4096 plus the VLAN ID of 4 equals 4100, and we see the MAC address. Now let's compare that MAC address to the MAC address of switch A, and you can see they're the same. So that's one way to confirm that now switch A is the root bridge for this particular VLAN, VLAN 4. Also, you'll notice now FA024 is the designated port, right? Because the root bridge, all of its ports are designated. They're in that role, and it's forwarding. So that's one way to set the root bridge for a particular VLAN. So that's the manual method, if you want to call it that, where we explicitly state what we want the bridge's priority to be in order to make it the root bridge. There's another option, and the command this time is spanning tree VLAN. We choose a VLAN number. This time we'll use 5. And instead of explicitly stating the priority, we're actually going to let the switch choose the priority based on whether or not we want this to be the primary root bridge or the backup root bridge. So we tell it we want it to be the root, and if we look at the two parameters, we have either primary or secondary. So let's go with primary. And as soon as we enter that command, the switch A is going to look at the current root bridge for VLAN 5 and figure out its priority. Now here's where switch A is very smart about figuring out what priority it should change to. If the current root bridge has a priority higher than 24,576, then switch A will automatically just change its priority to 24,576. And since we were using the default values of 32,768, then that's what's going to happen here. So if we jump out now and say show spanning tree VLAN 5, you can take a look at the root and the switch A bridge priority. Now the MAC address is matched, so we now know that switch A is the root bridge for VLAN 5, and the priority was changed to 24,576 plus 5 because we're talking about VLAN 5, and that's how we get 24,581. Now, if the old root bridge, meaning when switch B was the root, if its priority was below 24,576, then switch A would have figured out what it is and then just subtracted 4096, because remember when we manually set the priority we had to do it in increments of 4096, so it would have done that for us to ensure that switch A would become the root bridge. As a side note, if we wanted to make this bridge the secondary and we had chosen the secondary parameter, switch A would go ahead and set the priority to 28,672. Okay, so in a sense here, it's not automatic because we're putting the command in manually, but it is automatically choosing what the appropriate priority should be in order to make the switch the root bridge. Okay, so moving on, let's go ahead and change a port cost now. Here's a useful command. show spanning tree interface, and then we'll put FA24 since that's our trunk to the root bridge. And it will quickly show you all the VLANs that this interface is associated to, along with all the interesting stats. You can see the role, the status, the cost, and note VLANs 4 and 5 are now designated because switch A is the root bridge. Well, if we look at the cost column, they're all at 19, which means this is a fast Ethernet link between the two switches. Well, let's go ahead and change VLAN 7 from 19 to something else. Now, it's not going to change anything here because we only have one link to the root bridge. But I'll just show you how we can do it. This time we have to go into configuration mode for a particular interface. This is an interface subcommand. And the command is spanning tree. We always state our VLAN, and let's say VLAN 6, and then cost. And here you can see the range of values we can enter. If I want to make it higher, I can say 30. And now let's go ahead and reissue our interface command, and you can see VLAN 6 on FA024 has a cost of 30, and everything else remained the same. So we can fine-tune each VLAN one at a time if we want to. Okay, now let's take a look at how we configure PortFast and BPDU Guard. And as promised, these are going to be just as easy as configuring port cost. Both of these commands are interface subcommands, so if we want to apply them, we have to go into the interface. First, let's take a look at the interface configuration for FA08. And you can see it's a standard access mode switch port. So that's where we're going to go. And in order to enable PortFast, the command is spanning tree PortFast. After you hit enter, it's going to give you a little warning telling you when it's appropriate to use PortFast, and then it goes ahead and it actually enables it. So don't freak out if you see this. Just take a moment to read it. It's some basic information that you already know. Now, to enable BPDU Guard, the command is spanning tree BPDU Guard, and then you have to use the command enable. Now we're done. Show run interface 08, and you can see the two commands are configured for that particular access port. And I showed you those together because those two commands make sense to have them configured at the same time on user access ports. Okay, let's go ahead and configure root guard now. This is another interface subcommand, so you have to jump into that particular interface if you want to enable it. We're going to go ahead and do this on FA011, and the command could differ between what type of platform you're using. So if this particular one doesn't work, you might have to go ahead and question mark to see the available parameters to you. Let's keep that in mind. Spanning tree guard root, and if we jump out of configuration mode and we take a look at the configuration now, we can see there it is. Okay, and finally we're going to take a look at how we configure uplink fast and backbone fast. First, let's go ahead and take a look at the two verification commands for these features. Show spanning tree uplink fast, and this is currently disabled on this switch. And if we do the same thing, show spanning tree backbone fast, you'll also see it's disabled. Now these are two global configuration commands. So the first one is pretty simple, spanning tree uplink fast, and then spanning tree backbone fast. Now let's take a look at those show commands again. We'll start with uplink fast, and here you can see some information on it is in fact enabled, and then we get into some VLAN specific and interface specific information. So it's a quick way to verify if uplink fast is even enabled on your switch. That's uplink fast. Show spanning tree backbone fast also tells you the first thing right off at the top here. backbone fast is enabled, and then below it you'll find some statistics about backbone fast and how it's functioning on this switch. Okay, so pretty easy, right? Okay, and we're done. To summarize, these are all of the commands we issued in this tutorial. We started off with a few verification commands with the show spanning tree for a particular VLAN, all VLANs, or just the root for all VLANs. And then we went into the individual configuration commands for each of the features. Now remember, we didn't have to do any of this. Spanning tree, by default, is enabled and functioning as soon as you create a VLAN. But if you want to customize spanning tree to your exact network needs, then you do have to be familiar with these commands, and oftentimes they are implemented on a network. And then finally at the bottom, we had two more verification commands, and these were specific to uplink fast and backbone fast. Okay, and so that's it. That is how to configure and verify spanning tree. Thanks for watching.